Dear student, in the previous lecture, discussed about distance vector routing algorithm. Now today I will discuss about linked state routing algorithm. So first, distance vector routing algorithm was used in the ARPANET until 1979 when it was replaced by linked state routing algorithm. Two primary reasons caused its demise. First, since the delay matrix was Q length, it did not take line bandwidth into account when choosing routes. Second, algorithm often took too long to coverage even with tricks like the split correction. For these reasons, it was replaced by the entirely new algorithm called linked state routing algorithm. So linked state routing algorithm, the idea behind linked state routing algorithm is simple and can be stated 5 parts. Each router must discover its neighbor and learn their network address. Second, measure the delay or cost to each of its neighbor. Third, construct a packet telling all it has just learned. And fourth, send this packet to all the other routers and compute the shortest path to every other router. These 5 basic properties and process the method of the linked state routing algorithm. So these methods are explained with the help of example. Suppose linked state routing algorithm graph R contains 6 router R1, R2, R3, R4, R5, R6 and distance या cost given between the router R1 to R26, R1 to R32 and R2 to R32, R1 to R33 like that so on. So first, linked state routing algorithm create linked stating using package set like that. Each router send a packet and create gather the information of neighbor. R1 send packet. Each packet contains several information like sequence number, TTL time to live, and their adjacent value like that. R2 6, R3 3. Similarly, R3 sequence number R2 contain the neighbor detail like that 3, 2, 9. So each node are contain the information of neighbor using the sending the packet. Now, after sending the packet, the vector distance vector with the sequence information ETL are stored. Now next we count the shortest path between R1 to next router. So apply the shortest R1 routing table like that. So R1 to R1 use the cost 0 and R1 to R2, R1 to R2, R1 to R2, R1 to R3. Suppose R1 to R3, R1, R2, R3, R4, R5, R6. This is the destination. To apply the Discastra algorithm of this graph. Apply the Discastra algorithm like that. First we write the cost 6, R1 to R2 6, R1 to R3 3, and no direct part R1 to R4, R5, R6. So we take the distance R4, R5, R6 is infinite, undefined. Now we use the minimum distance of router is 3. So first we reach R1 to R3 and calculate value 3. So R1 to R3 circle is created and next maintain distance of adjacent of R3. Adjacent of R3 equal to R2. So 3 plus 2 equal to 5. Now first 6. So 6 is replaced by minimum of value. So R3 is use the value 2 plus 3 equal to 5. No direct path between both finite direct path of 5. So R3 3 plus 9 equal to 12. No direct path are 6 infinite. Now next R2 R3 is covered. So next Node are available 5, infinity 12, and infinity. Minimum value of node is 5, so we started from 5. Yes, R2. So travel R1 to R3 is completed to R1, R3 to R2. Now R3 to R2, we calculate the value of R4 12, we calculate the value of R5 is 12, and value of direct R6 not directly is infinity. Both are equal. So any of vertex are you choose, you have choose. So we choose here the R4 because R4 and R5 both have equal distance. So we first choose the R4 router. Now we travel from R1 to R3, R2, R4, and next travel this. So sequence we found R1, R3, R2, R4, and here we create the routing table. Routing table R1 to respect R2, R2 equal to 5, R2 equal to 5, R3 equal to 3, R4 equal to 12, R5 equal to 12, R6 equal to R6 equal to 16, 16 right here 16, and via R1, R1, R3, R2, R3, R3, R5. This is the example of link state routing algorithm. Now, again, we explain link state routing algorithm in terms of theory, in theoretical form. So, distance vector routing differs significantly from the link state routing with link state algorithm because routers share only the identity of their neighbors, but they float this information through entire network. Distance vector algorithm adopt an opposite approach. So router periodically share the knowledge of the entire network, but only with their neighbors. Learning about the neighbor means when a router is booted, it first task to learn who it is the neighbor. It accomplishes this goal to sending a special hello packet on each point-to-point line. The router on the other end is expected to send back a reply telling who it is. When two or more routers are connected by LAN, then situation is slightly more complicated. One way to model the LAN is considered it is node itself. So learning about number like that, an artificial node, and each node learn about neighbor using the sending hello. Next, measuring the line cost, the link state routing algorithm require each router to know or at least have a reasonable estimate of the delay to each of its neighbor. So the most direct way to determine the delay is to send a special echo packet over the line that the other side is required to send back immediately. By measuring the round trip time and dividing it by 2, the sending router can get a reasonable estimate of the delay. So measuring line cost, an interesting issue is whether or not to take the load into the account when measuring the delay. The factor the load in the round trip timer must be started when the echo packet is queued. And to ignore the load, the timer should be started when the echo packet reaches the front of the. This is including queue cost can be baseline and but may lead to routing table oscillating. And building a state packet like that, each packet A sequence number S and their neighbor like that, A their neighbor B and E, cost of B equal to 4, cost of equal to 5. Similarly, link B state C D E, each packet contain the information of neighbor. Building the link state package is to the hard part of determining when we build them. Periodically, when the some significant event occurs, such a line neighbors going down the coming back. So distribution link state packet like trickiest part of the algorithm is distributing the link state packet reliably. As the packet distributed and installed, the router getting the first one will change their rules. So consequently, different router may be use different version of topology, which can lead the inconsistent loop unreachable machine, and other problems. The fundamental idea is used to coding to distribute the link state packets. And distributing link state packet like that to keep the flood in check. Each packet contain the sequence number that incremented for each new packet. Sent router keep track all of the source router sequence where they see. So when new link state packet come in the checked against the list of packet already seen. If new forward on all line except one it arrived, and if duplicate the odd packet discarded. Distributing link state packet is some problem. A problem like that if the sequence number wrap around, confusion will design. And solution here is to use 32-bit sequence number with the link state packet per second. It would be take 137 years to wrap up. If router crashes, it will lose track its sequence number. So sequence number ever corrupted on 655540 is received instead of 41-bit error. Packet 5 through 65540 will be rejected as absolute. So this is the theory of the link state routing algorithm. And link state routing algorithm work according to this example to explain here. Thank you. In the next lecture, we will explain next routing algorithm like that hierarchical routing algorithm. Thank you.